Good morning, everyone. In this class, we are going to discuss about ocean's temperature. The ocean thermal engine, a global climate regulator. Okay, ocean temperature is a vital sign for the planet. It is a very important sign for our planet. It governs the distribution of marine life from microscopic phytoplankton and zooplankton to the largest sea creatures. It directly influences the climate of coastal lands and the life they support. The understanding its dynamics is key to understanding global weather patterns and climate changes. Now, what is the main source of this oceanic temperature? Okay, how the ocean gains heat? Okay, the primary energy inputs is come from solar radiation. Okay, the sun is the principal source of heat for the ocean. Energy arrives as shortwave radiation both directly from the sun and scattered from the sky. With a high sun and clear sky, 85% comes directly from the sun and 15% from the sky. Okay, shortwave radiation and scattered from sky. Okay, convection from Earth's interior and transformation of kinetic energy, chemical processes, and convection of sensible heat from atmosphere, condensation of water vapor. Okay, there are some secondary heating processes also. Convection of heat from the Earth's interior through the ocean bottom, transformation of kinetic energy, example from current and waves, into heat. Heating from chemical processes, convection of sensible heat from the atmosphere, condensation of water vapor at the sea surface. Now, how the ocean cools? Okay, after getting the temperature, how the oceans become lost its temperature? Okay, the balancing energy outputs. Okay, back radiation, convection, and evaporation. There are three types of processes of losing Earth's ocean's temperature: back radiation, then convection, then evaporation. Okay, back radiation, the sea surface radiates heat back towards the atmosphere and space. Convection, sensible heat is transferred from the warmer sea surface to the cooler atmosphere. Then evaporation, the process of evaporation removes significant heat from the ocean surface, transferring it to the atmosphere as latent heat. Okay, the slow, steady pulse of ocean temperature. Okay, diurnal 24-hour cycle and annual seasonal cycle. Diurnal range barely 1 degree Celsius. The highest temperature is reached around 2 p.m. and the lowest at 5 a.m. Okay, this is a daily temperature interval. Then annual season range, the maximum temperature is typically in August and a minimum in February, northern hemisphere, slightly delayed compared to land. Okay, long-term cycles. Periodic fluctuations also exist, such as the 11-year sunspot cycle, which can cause sea temperatures to rise. Okay, these are some variation of sea temperature during day and during season. To understand the ocean's thermal structure, we analyze its temperature in two primary dimensions. Okay, first of all, horizontal distribution. That means based on its latitudinal extension, and vertical distribution based on its depth, means height or depth of oceans. Okay, horizontal distribution examining the temperature patterns across the vast ocean surface, and vertical distribution explaining how temperature changes from the sunlight surface to the dark abyss or sea floor. Now, across the surface, a general decrease from equator to the poles. Okay, the global pattern, the average surface water temperature of all ocean is 26.7 degrees Celsius or 80 degree Fahrenheit. Temperature gradually decreases from the equator, okay, towards the poles. When we're moving towards the poles, the temperature decreases as solar insolation becomes less direct. Okay, the general rate of decrease is 0.5 degree Fahrenheit per latitude. A key temperature benchmark at 20 degree latitude 22 degree Celsius, at 40 degree latitude 14 degree Celsius, and near the poles 0 degree Celsius. Interestingly, the highest average temperature is recorded slightly north of the equator. Now, the influence of latitude and landmass. Unequal distribution of land and water. Northern hemisphere oceans receive more heat due to extensive contact with large land masses. Okay, in the northern hemisphere, there are a large number of land surface. That's why the oceans receives more heat from the contact of land surfaces, making them warmer on average 19.4 degrees Celsius than southern hemisphere oceans, then that is 16.1 degrees Celsius. Okay, northern hemisphere ocean is warmer in average than the southern hemisphere. This results in irregular, non-latitudinal isotherms in the north, and while isotherms in the south are more regular and parallel to latitudes. The effect of enclosed seas. Seas in low latitude surrounded by land become significantly warmer than the open ocean. Equator oceans 26.7 degrees Celsius, Red Sea 37.8 degrees Celsius because it's surrounded by land surface, and Persian Gulf is 34.4 degrees Celsius. This is a influence of latitude and land masses. Now, okay, winds and currents. The great distribution of heat, prevailing winds, offshore winds push warm surface water away from coast, causing upwelling of cold deep water. Example, eastern ocean margins in the tropics. Onshore winds pile up warm surface water against coastlines, raising temperatures. Example, western ocean margins in the tropics. Then ocean currents, warm currents and cold currents. Warm currents raise temperatures in the regions they flow to. Example, Gulf streams warm the North American East Coast and Western Europe. Similarly, cold currents lower regional temperatures. That is, example, Labrador currents cools the northeast coast of North America. This is the influence of winds and ocean currents in ocean temperature. Okay, now the vertical distance from the sunlit surface to the abyss. The fundamental principle is that the ocean is heated from the top down. Maximum temperature is always at the surface because it's directly get the temperature heat from the insolation. Temperature decreases with increasing depth, but the rate of decrease is not uniform. Okay, light penetration and thermal zones, fatigue zones, 0 to 200 meter, 0 to 200 meter, it's called as fatigue zone. The upper layer receives sunlight. Solar rays effectively penetrate up to 20 meter and rarely go beyond 200 meter. And aphotic zone, that is more than 200 meter, aphotic zone, this portion extends from 200 meter to the ocean floor. It receives no solar radiations. That's why it's cold than the first layer. Now the thermocline, a zone of rapid temperature change. Defining the thermocline, a transitional zone separating the warm upper layer from the cold deep layer, characterized by a rapid decrease in temperature with increasing depth, typically located between 300 meter and 1000 meter. Below 2000 meter, temperature change becomes negligible. Other types, seasonal thermocline from in summer at depth of 40 meter, 100 meter. Diurnal thermoclines can from in shallow water less than 15 meter. Okay, that is the concept of thermocline. Basically, it is a transitional zone between a warm layer and cold deep layer. Okay, the three-layered ocean of the tropics and mid-latitude. Layer 1, the upper layer, the thermocline, and lower layer. Depth, upper layer, top 500 meter, temperature warm, 22 degrees Celsius to 25 degrees Celsius. Notes, present year round in tropics, develops only in summer and mid-latitudes. Then second layer, the thermocline, depth between 300 meter to 1000 meter, temperature zone of rapid decrease. It acts as a barrier between the upper and lower layer. Then lower layer, layer 3, below 1000 meter to the ocean floor, temperature very cold and stable. Notes, it is a dense and vast mass of cold water. Exception, there is an exception. Polar seas typically have only one cold layer from surface to floor. Okay, because of its latitudinal isolation. Now, vertical anomalies and atmospheric interaction. Deep water temperature anomalies in some enclosed seas, high temperature persists at great depth. Example, the Mediterranean Sea records 24.4 degrees Celsius at 1820 meter, 29 meter, while the Indian Ocean at the same depth is only 1.1 degrees Celsius. This is common in enclosed seas in low latitudes. Then ocean atmosphere interaction, sea fog, cold sea surface. Fog forms where there is a significant temperature difference between the sea surface and the air above it. This occurs when warm moisture passes over a cold sea surface, cooling the air to its dew point, most common in high latitudes during spring and early summer. Okay, the dynamic system crucial to global climate. Key core takeaways. Ocean temperature is governed by a dynamic balanced solar heating and surface cooling. Okay, ocean temperature is governed by solar heating and surface cooling. Its distribution is three-dimensional. Okay, shaped horizontally by latitude, land, wind, and currents. Okay, vertical distribution. The vertical structure is defined by a three-layer system in most oceans, with the thermocline acting as a critical boundary. This complex thermal engine is fundamental to regulating Earth's climate and sustaining marine ecosystem. Okay, that's all for today. If you have any doubt and query, Just let me know in the comment section. Thanks for watching. Thank you.